Oh, hello everyone. Welcome to the class on Introduction to DevOps, Version Control Systems, specifically Git. My name is Akhil. I'm an assistant professor in Computer Science and Engineering in St. Martin's Engineering College. Today, I'm going to guide you through the Introduction to DevOps and also a version control system. And I'm very excited to discuss this topic with you. So first of all, what is a uh, let's have a question like what is DevOps? First of all, what is DevOps? So DevOps is a cultural and a professional movement that merges software development and IT operations to improve collaboration and efficiency. That means you might have already learned about software engineering processes in your software engineering second semester. This is a prerequisite. The knowledge of software engineering is a prerequisite to learn about DevOps. Now there we already have learned about this DevOps development and operations people who are working as a different teams. And here the DevOps emphasizes on collaborating these two people. And this is a movement. It's not a software. It's a movement, a cultural movement and professional movement that actually merges both the teams together and make it more collaborative. And today's fast-paced tech environment, organizations need to deliver software quickly while maintaining quality. DevOps enables this by fostering a culture of collaboration. As we already know, the projects nowadays are very big. Like earlier days when it's 1960s, 70s, the software projects were very small, and the need for DevOps is not that much required. But nowadays, as a very fast-paced movement in the software development, now the requirement for DevOps, such a collaboration movement, like to manage your projects better and to create your projects, big projects better, the need for DevOps is very much required. It's a crucial moment for to activate, like use such an active DevOps in your actual software development process. So, yeah. Yep. So, so this is actually an image which represents the DevOps teams in your software engineering team. Actually, the development team is someone who actually implements the projects, whereas the operations teams take care of operations such as actually taking care of deployment and maintenance of the project. So actually this collaboration of development and operation teams is a very important crucial point, and it's a very basic principle of DevOps. And we'll go through more principles of DevOps. So before going through the principles of DevOps, first let's get into more details of what's the need of DevOps, right? So for the traditional approach, development and operations teams worked in isolation, leading to delays and miscommunication. That means like earlier days when the DevOps is not used in your software development processes, what's happened is the development teams and operation teams are isolated and they are working as a separate teams. Now what happens, there is a very possibility, a great possibility of the miscommunications happening between the teams as they are not collaborated together, and this actually impacts the projects. So this actually could impact the projects at different ways. And a modern approach in the software, new modern approaches, actually what we are doing is we are using a DevOps culture. And here DevOps emphasizes a continuous collaboration, allowing faster releases and improved product quality. It's not only about the collaboration, but actually it's trying to improve the agility of your projects and also allowing for faster releases. That means it emphasizes a faster releases by using continuous integration and continuous delivery included in the DevOps processes. So, and also it's, as we are improving upon all these various things in your software development processes, it actually improves the product quality also, right? And here this is an image which represents like in the traditional way what it is to be, how the software teams used to be in the traditional older conventional way of software engineering, whereas the new DevOps way of software engineering. So here if you look in the earlier days, so the operation team, quality assurance team and the development teams, these teams work separately. right? So they work separately, and they are completely isolated. They are not at all collaborator anyway. And the thing is, only they will share, like think about a scenario where like a software developer has implemented something and he hand over his code to the operations team, a person, and he's waiting for the person to actually give the feedback. And it's very hectic process when the projects are very big and the team is very big, and people's communications, it could actually create a lot of disturbances in the releases. Because if the operations team is a person, if the developer depends on the completely on a single other operations person, it actually could impact sometime. So because of like the person might be actually not ready with his work, the operations person, even though the developer team has completed their work, these kind of issues could be there. But whereas in the DevOps methodology, if you are using DevOps in your DevOps culture, in your software development, in your team, what happens is you have a core team who are working the overall product, but there are a lot of cross-functional teams. The majority of the teams who are working on a multiple features, there is this cross-functional team. It contains of operations, assurance, and development persons, right? So actually, all the features which are implemented automatically delivered, okay, automatically delivered and automatically integrated, okay, all these kind of things will happen in each feature that is implemented because of the cross functional teams that are maintained in each feature, which each feature implementation. Whereas the core team is also contains like all the cross functional members, like cross functional, it is also a cross functional team which contains operations, quality assurance, and development. Next is the key principles of DevOps. So we all learned what is the need of the DevOps, what is actually DevOps and why we need it. But let's discuss about the key principles, what DevOps culture, what DevOps tells us to actually maintain. If you are a DevOps person, or if your organization is a DevOps organization, what are the key principles you have to actually maintain? So first thing is the collaboration. Second is automation. Third is continuous delivery, and fourth is the feedback loop. So these are the must have principles in your DevOps, because all of them actually makes your organization a DevOps oriented organization, DevOps focused organization. So first one is collaboration. It encourages teamwork between development and operation teams. It encourages teamwork between, that means it's not like isolated the development and operations team, rather a teamwork and the collaborative work happens between the development and operations. Automation, also the other focus area of DevOps is automation. So because we are focusing on the agility of your project, project development, software development, this is very important. The automation is very important because a lot of hectic processes, manual intervention is required in a lot of processes where it actually makes your process very slow. So removing all the manual intervention wherever required, because some processes it's not possible to completely get rid of these manual interventions, whereas there are some processes where automation can actually get rid of these things. So automation automates repetitive tasks to increase efficiency and reduce errors. So other thing this automation does, like it's actually increases the efficiency because manual intervention is not there, and its actual manual interventions could actually slow down your process, whereas this gets rid of that. It makes it more efficient, that it could actually increase the fastness of your project, right? Because also like all the mostly care, like we'll automate the processes which are repetitive in nature. Like some processes are not that much repetitive, and creating a separate software to do such tasks is it's not cost efficient, whereas some tasks are very repetitive. It's like happens daily 100 times or daily 10 times, and automating it through a software is actually more cost effective. It reduces a human, like a person required for that particular task to be done. So that's how it makes it more efficient. It increases efficiency, and also it reduces the errors, because manual interventions also leads to errors. Human errors are possible in software, like many times when you are implementing software, due to your concentration levels or some other reason, some manual errors, you could be typing error, it could be a typing error, it could be something else. That manual error happens during most of the projects. Actually during this automation, like Automation can be done like a configurations, where you are creating a configurations to your project, because like you typed some IP address wrong, and it could actually lead to a lot of disturbance in your overall project deployment, right? So those kind of errors could be actually reduced while automation. Software will not do such kind of errors. It could be a technical glitch, at some only very rare cases there will be some technical errors, but a majority of the times, 99% times, your software will do these repetitive tasks very better than a human being. Next is a continuous delivery. Continuous delivery ensures that software can be released reliably at any time. Like the another principle of DevOps is a continuous delivery. You have to maintain this continuous delivery. You could be using any tool or it could be any way, but the principle has to be followed. The principle of continuous delivery has to be followed. So for this, like in this continuous delivery, what you will be doing is it should be able to make your software delivered at any time reliably. That means whenever your client wants the new features to be deployed, so it should be ready to be deployed. That's what this continuous delivery tells about, right? It tells like whenever your client requires software to be deployed in the production environment, it should be reliably deployed. That is what continue. It should be ready to deploy all the times. The feedback loops. So the feedback loops also have an important concept here. So it incorporates feedback from all stages of the life cycle for continuous improvements. Okay, so all the times, like you already learned, like there could be some mistakes happens, even in the even the operation, the collaboration teams happens after the deployment. There could be some issues. Okay, all the issues could be resolved, and it should never happen for the future. So those kind of feedback should be taken. It should be continuous, and the changes required, and whatever the more like changes required in the process you are using and the methods you are using, those things should be implemented. So that's how the feedback loops works. And now let's discuss about this DevOps lifecycle. What is DevOps lifecycle? Because we already have learned about the software engineering lifecycle. There are many like various phases of software engineering. It's also mostly similar to the software engineering lifecycle, software development lifecycle. Whereas the things we are going to do is we are much focusing on the automation here. Also, the agility is very important, and the agility, along with agility, we are focusing on automating the things completely. And the first major thing is the collaboration. So these are the focus areas of DevOps, whereas majority of the phases, or if you have seen all the phases, those are actually similar to your software engineering, the software development lifecycle phases, right? So let's see, to go through all the phases. A plan, so it define objects and requirements. So while you are starting your project, you want to plan your project, you define your objectives, what you have to implement, and the requirements for your project. So what software you require, what hardware is required, and all other details, whatever requirements are there, it comes under the planning of your software engineering, like a software DevOps life. In the DevOps life cycle, planning your project, the plan is the first phase. The second phase is the coding. So after you have define your project, you defined all the the requirements and the objectives. What is the objective of this project? What we are going to deliver to the to our users? So that is what defined. After defining, you got to start your project. You start developing your project. So that's where you start coding your project, write your applications using some programming language. You start implementing your programs, that is your application. So that is the second phase. Whereas the build, compile code into an executable format. After building, it's not the code you are delivering to your users, to your clients, right? You are delivering a product that could be used, right? That could be used by users and end users. So after implementing your project, that is coding your project, you are going to build it. You are creating an executable format, executable file of that existing whole created project, and you are going to deliver them to your clients. So the next phase after building is, it's not directly you will be delivering the product after the build is complete, because there could be some mistakes that have done by the developers, or it could be any other glitch errors that might be a human error or any other technical errors that happens, could actually lead to a production loss, like for the people who are using, right? Your clients might lose some business out of, without checking whether it's running or not. You are delivering it and deploying it to the servers, and people started using it. It might create some loss to the clients. So what you are going to do is you are going to test your project, that is perform automated tests to identify bugs. Here automated test is a focus thing. That is because in the software engineering you are testing it, multiple different ways of testing you are using, but the thing is you are automating it here, automating test to identify bugs. If any bugs are there, you have to actually rectify those bugs. The next thing is a release, prepare code for the deployment. So now the release, new release, every time, like if you consider about application, very big applications like WhatsApp and Facebook, there are these releases every time it happens. Like every month they have a new feature added to your like application that you are using. This happens because each new thing you are seeing in your application is a new release, right? So this release is making the features ready to deploy to the users, to the servers, deploy to the servers and ready to use by the users, right? um, and next is deploy. So after it's ready to further release, and you will be deploying it to the servers. So deploy the application to the production environments. That means the servers which actually deliver the, you might have learned about the client server architecture. Whatever the web application, you are sending the client request from the client, and you are getting the responses from the servers. That means this application which is actually created the after building the executable file and also tested, you are going to deploy it into the servers. And after deployment you have to operate it. That means simply deploying it doesn't mean like there is nothing going to be wrong in the future, right? There might be some technical issues that actually might occur. It could be because of the server issues, server hardware issues. It could be any software update issues. There are a lot of different kinds of issues that could occur in the future. Actually you should have to take care of those things. That comes under this operations team. If you check, the majority of the part is these are the developers until you are deploying your application. After the deployment has to be taken care by the operations teams. So now the operation is monitoring the application performance. Now you have deployed it, you are monitoring it, you have deployed and checking whether the application is running, the performance. That means the speed of the application, whether it's proper, it has to run like the responses which you are getting from the application server is like from like whatever the things we already expected, or it's going beyond the time limit, right? Because if your application is slow, the users might actually not like your application. They might leave your application for the future. So these are actually effects on your business aspects. So operating, so and monitoring, gather feedback from users and system metrics. So there are some metrics, any application, like while defining your objectives, you have some metrics. You also created some metrics that actually takes care of how successful your application is, right? You will be monitoring those metrics, whether it's satisfied whatever the objectives we actually define, whether it's reaching those objectives or not, and gather the feedback from the users and the system metrics. In this particular monitoring period, in this phase, we are actually collecting the feedbacks from the users. So whether they are getting any problems during using this application, or you also actually looking into the performance at the same time, right? So these are the various tools that you are going to use in the multiple phases, right? So now here, let's discuss about one of the tools that you have seen earlier. So here the Git. So Git is coming under the version control system. Its role in the DevOps is a very crucial, right? So you are going to use Git for the version control system, whereas every developer nowadays who are developing, they must know about the one tool, that is a Git, right? So while starting your project, you have to learn, when you have to collaborate with the people, collaborate with the other developers. It's a must and required tool, because like to maintain your projects, the Git is a very crucial thing. So let's go further and learn about Git. So Git is a distributed version control system that allows multiple developers to work on a project simultaneously without interfering with each other's changes, right? So here, so it is a version control system. That means you are implementing your project and you are creating a file and you are changing it further, so on, and multiple times you change your application. But think about a scenario where your previous code, whatever you implemented, is required for you. You cannot go back to it. It's actually is a negative feed, like negative thing that actually you can't do it. So what this version control system is, like, you can actually create a different versions of your code while implementing your project. Actually, whenever you want to revert back into the previous versions, it's easy, because think about a production level code where you have created some new feature, you implemented it and you deployed it. Now suddenly it stopped working. But if you don't like, it's taking time to debug the whole application. Think about like what you can do further, like it's taking a lot of time to debug your application. The thing is, you can actually get back to your previous version, revert to your previous version by using the version control systems, right? And here it's a distributed version control system. That means like multiple developers can actually download the whole source code in their local systems. It's distributed towards all the systems, and also can work simultaneously. Okay, developers to work on the project simultaneously without interfering with each other's changes. So all the developers can actually work on a single repository, but not actually bothering about the changes made by the other developers. You can work on your part of your application, what you are going to implement. Git enables teams to collaborate effectively, track changes, and manage code versions seamlessly. This is like a track changes. This is a important point. So it actually tracks the changes, whatever the changes you are making. It continuously tracks the changes that's happening in your code. That actually helps. That is a major point of a version control system. It whenever you want to go back to previous versions, it makes you, the tools of Git actually helps you get there back. And it also helps collaborate effectively. That means like you, because it's a distributed version control system where people from multiple places can actually work on the same repository without bothering about the others changes made. So that's actually improves the collaborative. You can work on the single repository. That is what the collaboration means, right? And manage code versions seamlessly. Like you can actually store the different versions of the code. That actually I already told about the scenario where like you could get into some problem of a deployment. You can actually get back to your previous versions, right? So this is all about Git. And let's check like the features of Git. Okay, what are the features of the Git? So Git has a distributed architecture. Every developer has a complete copy of the repository, enabling offline work and full access to the project history. So we already discussed this. Like all the developers who are working on the particular project has a repository downloaded in the local systems, right? And branching and merging is another feature. And the thing is, this branching, developers can create branches of new features and fixes without affecting the main code base, facilitating parallel development. So here, so let me explain, like you have created a repository. You have created, so you have created a repository in your, so repository. Now the project repository is actually like developer, like 5 developers are working on this particular repository. Think about like a different developer is working on a different feature. Now what happens whenever you are creating a repo, you are working on this particular repository, if you are making the changes directly, the different developers, okay, different developers are working, okay, different developers are working on their local systems, okay, on their local systems. Now if they are making changes directly to the repository, okay, think about the scenario, the developers are making changes directly in the repository. This repository mainly like these kind of tools, whenever we are doing for the collaboration, what happens, these local systems can't be connected directly because they are not connected through any internet, or any network is not, any network is isn't available between these systems, you can't collaborate directly with the other developer. The thing is, for to do these kind of things, we are using something called like GitHub, right? So this actually is a cloud application where you can the Git is actually hosted. Now what happens, this repository can be hosted on GitHub and the developers can collaborate through this repository. And now think about the scenario where all these developers are working on a single folder, and by mistake a developer has made some mistakes, made some changes on this developer 2's file, developer 1, developer 2 and developer 3. Three of them are working on three different files. Now by mistake developer 3 has made changes on developer 2's files. It could actually impact, okay, the debugging process, and he has to work a lot to crack, because he know everything he created is right and it's perfect, but now something is not working, so he has to debug it back. So these kind of issues actually impacts the agility of your project. That's why there is a feature that is actually called branching. Okay, you can actually create multiple branches of your repositories, and these people can work on different branches separately. Now what happens, developer 1 works on branch 1, developer 2 works on branch 2 on a new features. And the thing is, what happens after making the changes, here the repository is different from these repositories. Then what is the other feature that is available in Git is merging. You can merge the changes made into the parent repository. That's how the merging happens, the branching and merging works. And okay, so now that is about the branching and merging and staging area. So changes can be staged before committing them to the repository and allowing to careful review before finalizing the changes. That means whatever the changes you are doing, before making the changes directly into the parent repository, there is this thing, before committing the changes to your repository, there is one thing called as staging in Git. Actually helps in to check whatever the quality assurance or other things happens, those things should be happened before committing your application, committing your changes to the application or the repository. All the changes will be reviewed and then only finalized. So this stage is called as a staging area of your Git. So here is an animation that actually represents so now we discussed about Git and also DevOps. Let me discuss about some operations that we can do in a Git, right? So here it is a video. Here we are playing a video, and these are various operations, like the stages at which, like a file, whatever the file you are creating, a new file in a Git repository, these are various stages. First of all, like when you started creating a Git repository, an empty repository will be there, and when you start creating changing and adding the files, the working directory, it will be, the stages will be changing. So we'll discuss about the various staging areas and also various stages that actually the files goes through. And also here, whenever you created a new file, and the command you are going to use is a git add. It will actually create the file to be in a staging position, which actually is ready for the commit for the next stage. And after the quality assurance happens, then you will do the git commit. So then after the git commit, after the git commit, what the files will be actually updated in the repository. So here we can check about various stages. Okay, so here in the working directory, there are three stages first, untracked, modified and unmodified. That means whenever you made any changes to the files in your working directory, firstly it is untracked. That means no changes were tracked by the Git. After you are adding it and you are modifying, you are adding the files, then it is modified and also tracked by the Git. When you made it Git add, then it is modified and also staged. It will come to the staging area. Now after it is staged but also unmodified, whenever you want to make like the commit, after committing it is modified and it will be updated in the Git repository. Now after the completion of the commit, it will again be in an unmodified mode, like because you are not adding any files, it is in an unmodified mode. And later again the cycle again goes on, like whenever you add new files and you made changes to the files, the work directory will come into this stage, right? This is about Git. And thank you all for the session. Yeah.